Good day, madam. We are from TT5L Group 5. I'm Yun Shan, and today we would like to present our project, Student Club Management System with Budget and Revenue Integration. These are our team members, and here are the tasks we have completed. First one is about team formation and project overview. We decided to use Microsoft Teams and WhatsApp for communication, also GitHub and OneDrive to share documents for working together easily. Next part is project preliminary. Our vision is to build a centralized system that improves student club operation. The scope includes students can register as a member by joining clubs. The system provides forum for discussion and idea sharing. Also, club leader able to create event proposal, submit venue and budget requests for staff approval. The goals of this project are to streamline club management, to support event and venue planning, also enable real-time budget tracking, provide a communication platform such as discussion forum. Next, in task 2, we have identified those 8 context objects. Here is the table, shows the objects and sources. The context objects include student club, member, event, forum, budget, venue booking, financial management system, and also campus reservation database. We also determine the requirement source from this object. Example like student as stakeholder identified from student club, club leader also stakeholder that identified from object forum. For the type document, which is event planning form identified from object event, also the financial system from object budget. Move on to task 3. We plan the elicitation process using 3 selected techniques: observation, questionnaire, brainstorming to identify potential requirements for the system. And we will then classify the requirements using the tunnel models to prioritize features that user needs. The first technique is observation. We plan to observe and review click system by performing tasks like venue booking, budget submission, and each task conduct between 5 to 10 minutes. The expected requirements include create event proposal, submit budget request, venue booking, view club. The next technique is questionnaire. We plan to create a Microsoft form to collect user expectations. The first step is to design questions into different sections, and then we distribute at least 20 students through WhatsApp group. We will also constantly monitor the responses. The expected features from these techniques are join or lead club, receive notification, and also create polls in forum. And the last one is view financial report by the club leaders. The last technique we use is assistant technique, which is brainstorming. All team members will collaborate using Microsoft Team Chat to propose ideas. The features and expected requirements include the important and essential system features like RSVP to event. Also, user can update their profile details. We also plan to generate some creative features like intelligent budget and venue booking recommendations. Here is the timeline. We aim to conduct and complete these all activities within 2 weeks. That's all from me, and I will pass it to Yun Xuan to continue with the classification of potential requirement using Kano model.
Hello, Madam. I'm Tan Yunshan from Group 5, and now I'll be presenting the classification of requirement using Kano model. So before that, our member has introduced our task tree, and now this is the last part of the task tree. So with three techniques used: observation, questionnaire, and brainstorming. Now let's see. Kernel model has three important parts, which are dissatisfier, satisfier, and excitement. So through the techniques, we classify them into these three parts. As you can see, basic things like secure SSL login, roles-based access is in dissatisfier, view financial reports and RSVP to events are in satisfier, and like smart budget suggestion and many recommendation are in excitement. So in task 4, I'll explain the outcome for each technique we use for elicitation. First, we observe the MMU click system with our student interacting with the current system, especially tasks like booking venues and submitting event proposals. And then we identify and classify them into three using Kernel model, which is the dissatisfier for the bookings of the bookings operation, the proposal sending, and then for the satisfier is like committee organization, and director is for like giving them a calendar view for the events. So these are the classification tables of the observation. We can see that there are three parts, and then this one is based on the observation. And then now for the questionnaire, we receive responses from two types of user. So you see here is the demographics. 85% are club leaders, community or regular member, and 15% did not involve in any club activities. Okay, so we can see that through the questionnaire, 92% of the respondents says that easy join or leave system would be good for them. They want it. And 96% of the respondents supported having notification and discussion forum. So 52% of the respondents prefer using QR code for attendance, which leads to the main point, the pain point, the manual attendance. 39% say that manual attendance was frustrating for them. So this is the classification of requirement. And this one is the dissatisfier, join or leave club, like satisfier, track event, attendee, view financial reports, use discussion forums. So last technique we use is brainstorming. So through the session, our group member provide ideas related to user needs and give possible system features, like personalized dashboard based on user role, a clear event calendar with reminders and RSVP options and notification, smart suggestions for budget and venue based on event type, collaborative task boards for committees to manage responsibility more effectively. So based on this idea, we classify them into dissatisfier like secure login via university SSO and role-based access control to differentiate between regular member and club leaders. Satisfiers such as view and update profiles, and detectors such as receive intelligent budget or like venue suggestion based on event type. So through this task, we are able to get to know which requirement suits the user the most in this student club management system. Thank you.
Okay, greetings, Miss. My name is Marcus, and I'll be presenting test 5. So, let's start with the purpose. Our software is designed to improve coordination among students, clubs, and university staff by centralizing all club-related activities, event planning, venue booking, budget tracking, and announcement into one easy-to-use platform. So everyone can stay informed, communication is clear, and student club operations run smoothly. So next, we'll be presenting the scope. The software is a web-based platform designed to manage student club operations. It is accessible to student club leaders and university staff, providing a centralized space for communication and coordination. The platform integrates with existing university system for authentication, financial processing, and venue management to streamline all related activities. And for the product overview, the product is a web-based platform that helps manage student club operation by bringing together communication, event planning, and resource resource management in one place. It integrates with key university system, including the financial system, which handles budget tracking and funding for club. Next, we have product perspective. The product is a web-based system built to work within the university's existing infrastructure. Its core features allow students to view and join clubs and events, enable club leaders to create events and book venues, while letting the staff approve budgets and venue requests. The main users are students, club leaders, and finance staff. The system only supports university recognized clubs, so it does not handle like off-campus events and stuff like that. Next, we have definitions. Okay, we have application, venue, booking, financial management system, authentication system, and SSO. Next, we have project perspective. The project integrates with three main systems: the authentication system to verify user identities and role, the financial system to handle budget and funding transactions, and the venue reservation system for booking university spaces. The primary users of the platform are students, club leaders, and university staff. Okay, for the performance requirements, the system is designed to deliver fast and reliable performance, ensuring a quick response time for all users. It must handle concurring usage smoothly, supporting many students, club leaders, and staff accessing the platform at the same time without slowdown or crashes or bugs, etc. The platform efficiently manages data handling by processing and storing event, budget, and booking information accurately and securely. Scalability is also a key requirement, so the system can grow and accommodate increasing numbers of users and data as the university community expands. So next, we'll be presenting the usability requirements. The system is designed to be user-friendly, focusing on test simplicity, so users can easily navigate and complete the activities without confusion. It emphasizes learnability, allowing new users to quickly understand how to use the platform. A consistent user interface ensures that the look and feel remain uniform throughout, making the experience intuitive. Accessibility is also a priority, so the platform can be used by everyone, including those with disabilities. Next, we have interface requirements. The system includes several types of interfaces to ensure smooth operation and interaction. The system interfaces connect the platform with external university systems like authentication, financial, and venue reservation system. The user interfaces provide a clean, intuitive, web-based experience for students, club leaders, and staff to easily access and manage club activities. The hardware interfaces involve compatibility with devices such as desktop, laptop, tablets, and mobile phones. The software interfaces support integration with existing university software and databases. Last but not least, the communication interface handles data exchange securely and efficiently between the platform and external system, ensuring real-time updates and reliable information flow. So that's all from me. I'll pass to the next person. Thank you for listening.
I'm Jingli, so I will be presenting the logical database requirements and software attributes of our proposed student club management system. So this is our logical database structure supports several key functions: user management, club operations, events, financial tracking, and venue reservation. So these are connected through a class diagram we will explore shortly, with clear entity relationships and access rules based on the user roles. So moving on to the types of information by function. So each system or function uses specific data, like user management needs authentication credentials and profile information like name, email, and role. And the club functions uses membership records, and events rely on the RSVP data. So daily interactions are most common with the user logins and forums, and the budget and menu requests are occasional but critical during event planning. So daily interactions are most common for the user authentication and discussion forums. So because they could every day log in, and posting, editing the club updates, and the event RSVP and notification will be medium because like RSPP will be only increased during event seasons collected before the events. Meanwhile, the budget and venue requests and the financial reports will be low because like the financial reports we only just generate each semester for tracking club finance. So access to system features is based on roles. For example, students can join clubs and RSVP to events, while club leaders manage proposals and events. Finance and venue staff have dedicated approval rights. So this role separation helps keep operations secure and streamlined. So our system uses well-defined entities like user, club, event, and proposals. Relationships are enforced through foreign keys. For example, a proposal is linked to budget and venue requests. So constraints ensure data quality such as valid status for approvals and predefined event types. So for the security and data retention, security is a priority. We use SHA 512 hashing for passwords, HTTPS for communications, and session-based authentication. Sensitive data like budget and reports are only visible to authorized users. Data retention follows clear policies, like student data is stored for 5 years, events and forums is stored for 2 years, and the financial reports is stored for 7 years. So the system is designed to be reliable, secure, and scalable. It maintains 99.9% uptime and works across platforms. It's also built for usability with responsive design and fast task execution. Most key actions takes 3 clicks of fewer. Our verification process includes unit integration and security testing across QA and staging environments. User feedback has been overwhelming positive. 96% of users want notification and forums, while over 90% support event RSVP and financial visibility. These findings guided our future priorities. And to summarize, our student club management system will not only currently solve operational inefficiencies but also foster greater student engagement. And that's all from us. Thank you.